So what I wanted to do today is to show you guys how to do some of these um, uh, problems working with isotopes and relative isotope abundance. All right, so if we get remember that the masses that we get from the periodic table are averages. Okay, so they're averages of all of the isotopes, and they're weighted. They're a weighted average. That is, if 99% of my atoms have a mass of 23 and 1% has a mass of 24, I'm going to be much closer to 23 than to 24. Okay, so if I look at this problem, it says boron has two naturally occurring isotopes, boron 10 with an abundance of 19.8%, that is 19.8% of the atoms are this isotope, and another isotope, boron 11, it's about 80% of the atoms and has a different mass, and we want this is actually should read the average atomic mass of boron. Okay, so the atomic mass, and again this is average, it's the mass of A times the percent abundance of A, and actually expressed as a decimal. So percent of A plus the mass of B times the percent of B. Okay, so we do need to convert these percentages to decimals, so we're just going to move the decimal point 2 places that way. So what we get is we get the mass of A, in this case will be boron 10, 10.013 atomic mass units, times 0.198 plus the mass of B, which is 11.009 atomic mass units, times the percentage of B, 0.802. All right. If we go and we put this in our calculator, we get, I'm going to be lazy and use my phone as a calculator. I'm still playing with my drawing program. So if we work that out, 10.013 times 0.198, we get 1.98 plus 11.009 times 0.802 is 8.83. If we add those together, we get 10.81. We're going to round to the hundredths place. There's my average atomic mass. Okay, so that's this one here. All right. Remember, we can also do in this, right, we can give you the atomic mass, some of this information, maybe the mass, and then have you find the percent. Okay, so it's not always, you're not always just calculating the average atomic mass. All right, we'll do one more here. Calculate the atomic mass of magnesium. You have 3 isotopes, and it gives their relative abundances. Okay, so the formula, right, really should be ... MC percent C and so on, however many isotopes you're dealing with. I think about 3 is as much as I would throw at you here. All right, so for number 17, you have 3 different atomic masses of the 3 isotopes and the relative percentages. Okay, so to get the average atomic mass, I'm going to take the mass of A here, 23.985 AMUs, and I'm going to multiply by the percentage expressed as a decimal, 0.7899. I'm going to add the mass of the second isotope, 24.986 atomic mass units, and I'm going to multiply by the relative abundance of that isotope, and then I'm going to say for the third isotope I have 25.982 times 0.1101. All right, so if I put that in my calculator, 23.985 times 0.7899 is 18.95. 24.986 times 0.1 is 2.49. And 25.982 times 0.1101 is 2.86. Sorry, I'm just going to leave that messy for a minute. Plus 2.49 plus 18.95. And I get an average atomic mass of 24.30 atomic mass units. All right, I hope that helped. Please remember, I could have given you this and asked you to find any one of these things, right? Ask you to find that. I could have asked you to find that, given the rest of the information. So just keep that in mind.